Hello everyone, I welcome you all to Startup Academy, your online gateway to success in ISS exam. This academy is exclusively for ISS only, and we are focusing on ISS 2026. We have completed the topics econometrics, and we are currently doing sampling techniques, in which we have covered almost major topics of sampling, which is simple random sampling with and without replacement, stratified random sampling, systematic random sampling, ratio estimator, product estimator, regression estimator. Today, we'll be continuing with the regression estimator. The first case in which beta was known, we covered it yesterday. Today, we'll cover the second case in which beta is unknown. So, let us begin. Case 2 says when beta is unknown. We know that the regression estimator can be represented as y bar minus plus beta capital X bar minus small x bar. This is the value of beta. Okay. So now here let us consider let us take approximation up to first order. If we consider this, let us consider y bar is equals to 1 plus e1 capital Y bar, small x bar is equals to 1 plus e2 small x bar. Now this beta can also here be written as y bar plus sxy upon sx whole square capital X bar minus small x bar. We did it yesterday that beta is nothing but sxy upon sx square. So we can take sxy is equals to 1 plus e3 sxy and sx square is equals to 1 plus e4 capital S x square. Let us consider these four variables. So putting the value of these variable in the above equation, we will get the estimator or the regression estimator as small y bar was nothing but 1 plus e1 capital Y bar, then beta. Beta is sx square upon sxy upon sx square. So 1 plus e3 sxy upon 1 plus e4 sx square into small capital X will remain as it is and small x will be 1 plus e2 capital X square. Now solving this equation, we will be getting 1 plus e2 y bar plus 1 plus e3 into 1 plus e4 raised to the power minus 1 sxy upon sx square into capital X bar minus x bar minus e2 capital X bar. This and this will get cancelled. This is nothing but beta. So substituting the value, we will get 1 plus e2 y bar plus. Now we have a minus sign here. So instead of plus, it will be minus 1 plus e3. Now this expansion of 1 plus e4 raised to the power minus 1 will be 1 minus e4 plus e4 square minus e raised to the power e4 raised to the power 4 and so on. But we have to take up till first approximation, so it will be 1 minus e4 only. And then we have e2 beta capital X bar. So now the formula can be written as 1 plus e2 capital Y bar minus 1 plus E3 into E2 minus E2 E4 beta capital X bar. Here we can write it as the regression estimator as y bar minus capital Y bar is equals to E2 Y bar. It is E1. E1 Y bar minus beta X bar into this will be E2 plus E2 E3 minus E2 E4 minus E2 E3 E4. Now since we are taking first approximation, so all these terms whose power is greater than 1 will be cancelled out, and our final answer would be regression estimator minus y bar is equals to E1 y bar minus beta x bar E2, since only E2 was left here. So now we will first check for unbiasedness for this. So unbiasedness would be estimation of regression estimator minus y bar is equals to estimation of E1 y bar minus beta x bar E2. This will be nothing but y bar into estimation of E1 minus beta x bar into estimation of E2. Now we know that estimation of E1 and estimation of E2 is nothing but equal to 0. This we have done again in the previous lecture. So if you're watching the lecture series in the series, then you should be clear with the concept, and if you're not, then watch the previous video. I would suggest that we have done it in detail there. So it will be 0 only, and this will become estimation of regression mean minus y bar. So this says that estimation of regression mean is nothing but y bar, and hence we can say that mean of regression estimator is an unbiased estimator of population mean, which is y bar. So it is unbiased. Now the second step would be finding the variance or mean sum of square errors. So finding MSE of regression estimator. This will be nothing but equal to estimation of mean of regression estimator minus y bar whole square. Now mean of regression estimator minus y bar is nothing but estimation of this equation 1, E1 y bar minus beta x bar E2. E1 y bar minus beta x bar E2 whole square. Now for this, first we have to derive estimation of E1 square and estimation of E2 square. So we know that estimation of E1 square is nothing but estimation of y bar minus capital Y bar upon capital Y bar whole square, which is nothing but 1 upon capital Y bar square estimation of y bar minus capital Y bar whole square. It is nothing but sy square upon y bar square. Similarly, estimation of E2 square would be estimation x bar minus capital X bar upon capital X bar whole square, which is 1 upon capital X bar estimation of small x bar minus capital X bar whole square, which is nothing but Sx square upon X bar square. And similarly, estimation of E1, E2 would be estimation X bar minus capital X bar into Y bar minus capital Y bar upon capital X bar into capital Y bar. This will be 1 upon capital X bar into capital Y bar, and I'm directly writing it as Sxy. So these are the three points that we'll be needing in this. So MSE of regression, mean of regression estimation is estimation of y bar E1 minus beta x bar E2 whole square. First we'll open the whole square part. So it will be estimation of y bar square E1 square plus beta square x bar square E2 square minus 2 beta beta x bar y bar E1 E2. Taking in the estimation, we will get y bar square estimation of E1 square plus beta square x bar square estimation of E2 square minus 2 beta x bar y bar estimation of E1 E2. Now estimations we have calculated in the previous page, which is E1 square, E2 square and E1 E2. We'll put directly the values here. So y bar square is sy square upon y bar square plus beta square x bar square estimation of E2 is sx square upon x bar square minus 2 beta x bar y bar estimation of E1 E2 is sxy upon x bar y bar. Now there is one more thing that should come here, which is multiply it by f by n, where we know that f by n is nothing but the f by n is nothing but, if we take out the sample from simple random sampling without replacement, this is f by n. So I am pre-multiplying all of it with f by n. Now here y bar square and y bar square, x bar square and x bar square, x bar y bar and x bar y bar gets cancelled, and we are left with f by n into sy square plus beta square sx square minus 2 beta sxy. We know that beta sxy rho, which is correlation coefficient. Correlation coefficient can be written as sxy upon sx into sy. So we can write sxy as rho sx sy. Substituting the value, we will get mean sum of square of errors of mean of regression estimator is nothing but f by n into sy square plus beta square sx square minus 2 beta into rho sx into sy. So this is the derivation of our mean sum of square of regression estimator. Now if we comparison with Comparison of regression estimator with simple random sampling without replacement. If we compare it, we know that variance of y bar in simple random sampling without replacement is nothing but n minus n upon n into n sy square. This can be written as f by n into sy square. Now compare this with that. We'll subtract mse y bar r minus variance of y bar simple random sampling without replacement will be f by n into sy square plus beta square sx square minus 2 beta rho sx sy minus f by n into sy square. So this whole term and this term will get cancelled and we are left with f by n into beta square sx square minus 2 beta rho sx sy. Now there arises two cases. Case 1, when rho is equals to 0, and case 2, when rho is not equals to 0. When rho is equals to 0, then we know that variance of, or simply write that, both regression estimator and simple random sampling without replacement are equally efficient. And when it is not equal to 0, hence we can say that our regression estimator is more efficient than simple random sampling without replacement. This was the comparison between simple random sampling and regression estimator. There is also one more comparison between ratio estimator and regression estimator. Comparison between ratio estimator and regression estimator. Now the formula for MSC of ratio estimator. Was f by n into sy square plus r sx square r square sx square minus 2 r rho sx sy. This was the formula. And for MSC of regression estimator, which is y bar cap small r, it can be written as f by n into sy square plus beta square sx square minus 2 beta rho. Instead of rho, we can write it as sxy. So substituting the value of beta, beta was nothing but sxy upon sx square. So substituting the value of beta in this equation, we will get f by n into sy square plus sxy square upon sx square का square. So it will be sx raised to the power 4 into sx square minus 2 sxy upon sx square into sxy. Here this 2 will get cancelled by this 4 and it will be 2 only. So it will be f by n into sy square. This is plus sx square upon sx square. This is minus 2sxy square upon sx square. So it will be minus sxy square upon sx square. Further, it can be written as, we know that rho is nothing but sxy upon sx square. So in sx into sy. So sxy upon sx can be written as sy into rho is equals to sxy upon sx. Substituting the value here, we will get f by n into sy square minus sy square into rho square. Taking the square because here the term is in square, so it will be this. So our final mean square of error of regression estimator would be f by n into sy square plus 1 minus rho square into sx 1 minus rho square. Now taking the comparison, we will subtract mean square error of regression estimator from ratio estimator. It will be f by n into sy square plus beta square sx square, not beta square, it will be r square sx square minus 2 rho r sx sy minus f by n into sx sy square minus rho square sy square. So this term sy square and sy square will get cancelled and we are left with f by n into r square sx square plus rho square sy square minus 2 rho r sx sy. Here we can see the formula for a minus b whole square, which is a square plus b square minus 2ab. So it will become f by n into r sx minus rho sy whole square. And we know that whole square of any term, square of any term is always greater than or equal to 0. So when this is the case, the MSC of mean sum of error of ratio estimator is always greater than equal to MSC of regression estimator. And hence we can say that regression estimator is always more efficient than ratio estimator. This was the comparison between regression estimator and ratio estimator. This completes our topic of estimators. Till now, we have been doing all these estimator for single sampling, in which we take only one sample. Now we'll start with another topic, double sampling, from tomorrow's lecture. So in that also we'll be doing the three estimator: product, ratio, and regression estimator. I hope you are doing what we are doing in the class continuously and with consistency. Keep on working hard and we'll achieve our goal together. All the best. Thank you.